Okay, in this video I will be explaining how to implement the Wheatstone network in the lab, and we call the apparatus which we use as meter bridge. So this is how it will look. See, I'll just draw the Wheatstone network for reference in the corner here. This is one resistance P, this is a resistance Q, this is a resistance S, this is a resistance R, and this will have the galvanometer G. Right? Yeah. And then we need to connect it to the battery. Through a key. So this is the circuit I want to implement. Let me also label it: resistor P, resistor Q, resistor R, resistor S, galvanometer G, battery of EMF, say voltage V. Okay, so it will be like this. The meter bridge consists of thick brass plates like this, the L shape like this, and then here you will have another thick brass plate, then you will have one more thick brass plate. Okay, now between these two brass plates a 1 meter long resistance wire will be connected. Actually current can pass through it, but it has a resistance and its diameter is uniform, so that its resistance is proportional to its length. Okay, so let's draw that wire. So this is the meter bridge wire. So you will have a wooden scale attached next to it. So let me draw the scale here. Oh, this diagram has turned out to be a little tilted. Let us see if we can rotate it. It's either too much rotating or too little rotating. It's okay. Let me delete it. I'll draw it manually. So this is the meter scale. Clear? It will have divisions like this, which help you to measure the position on the wire, meter bridge wire. Clear? From 0 to 100 centimeters it will be marked. Okay, so now there are connection points here. here, 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 and here. So I'll connect a resistance here. So can you tell me which resistance it is in this circuit? Let me call this point A, B, C, D. Okay. So the A point corresponds to here in this meter bridge, and C corresponds to this point. Okay. So B corresponds to this point, this middle brass plate. See, all the points in a brass plate are connected. It's a short circuit of this brass plate. So this point, this point, this point, they are all point B only. This entire brass plate is point B. So this entire brass plate is point A. So this also will be called A. This is B. This point is also B. And this point is also C. Okay. So between BC you have a resistance Q. So I can connect resistance Q here. So this is resistance P. This is resistance Q. Now you will be wondering, where do I put resistance R and S? Resistance R and S will be in this meter bridge wire itself. Okay. So the galvanometer will be taken from point B. So from point B I will take this galvanometer like this. Let me label it G. And then I will have something called as a jockey, using which I will tap onto this meter bridge wire. You getting it? See, this wire, this jockey, it's like a knife edge. So I can hold it in my hand and tap this metal wire wherever I want. So if I tap it at this point, then the part of the wire from point A to the point where I tapped it, that would have some resistance, that would represent this resistance R. Are you getting it? And the remaining part of the meter bridge wire from here to here would represent resistance S. Are you following? Yeah. See here, point B to point D is G. So this point is D. The point where I tapped the metal jockey onto the wire, meter bridge wire, is D. So AD is a resistance R. DC is the resistance S. So this is DC. So this is resistance S. Are you following? So this is resistance R. This is resistance S. So that's how a Wheatstone network is implemented in the lab. So now I want to make sure that it is balanced. It will be balanced when the current through galvanometer is 0. So suppose when the jockey is placed at this end, the resistance R is too little, right? So suppose P by Q is, say, 1. Let's start with the simple case where P by Q is a ratio of 1. Now the current through galvanometer will become 0 only when P by Q is equal to R by S. That means R by S should also be 1. So now you know that resistance is proportional to the length of the wire. So resistance of R is proportional to this length. Resistance of S is proportional to this length. If P and Q are both equal, say 100 ohms, 100 ohms, the ratio is 1. So can I take R to be 20 centimeters? Will it balance? What? How can it balance? If R is 20 centimeter long, this would be 80 centimeter long.
Yeah.
So this resistance is 4 times more than this resistance.
Yeah.
So the ratio of R by S would be 1 by 4. Then how can it balance? That's why it won't balance. So the galvanometer will show current. It will show deflection. So if you want to balance it, where should I place the jockey?
1840. That is 80, no? 100, no? 50.
So I should place the jockey at 50. If I place it at 50, A to D the distance would be 50 centimeters, D to C the distance would be 50 centimeters. Both will be wires of equal length and hence equal resistance. So the ratio of the resistances would be 1. So P by Q would be equal to R by S, and so no current will flow through the galvanometer. Are you getting it? So we need a formula to calculate so now we can use it to find unknown resistance. Let us say Q is a unknown resistance. We don't know the resistance of Q. So how can we find out? So we know the resistance of P. Okay? And using this setup, we are supposed to find the resistance of Q. So we will make use of this. So R by S is equal to, so now let us say the balancing length is L. So this length is L. So L is the distance between point A and point D, where D is the point where the current through the galvanometer is 0. The needle of galvanometer is at 0 position. If this distance is L, what is the length between D and C? Total length from A to C is how much?
From A to C. So
100 centimeters. I told you it's a meter bridge. It's a 1 meter wire.
100 minus L.
Yes. So it will be 100 minus L centimeters.
So
this is L centimeters. So this ratio will also be equal to the ratio of the lengths, which correspond to the resistors R and S. So it will be equal to L divided by 100 minus L. Agreed?
yeah.
So the unknown resistance Q would be equal to 100 minus L into P.
PR by S.
R and S you don't know. Instead of that only you are having this.
Oh, okay.
Or we can write it like this.
PL by 100 minus L.
So let's put a rectangle around it.
PL minus PL by 100 minus L.
So Q is equal to P into 100 minus L by L. Q will come this side. That is equal to P into 100 minus L by L.
Yeah. So 100 minus L into Q by. That's what now.
I want to find Q.
Yeah, you want to find Q now.
So this is the formula to find the unknown resistance Q.
That's what I said.
So I just have to adjust the position of the jockey on this meter bridge wire till it shows 0 deflection. So I will note down the value of L and 100 minus L, and I already know the resistance of P, so I can calculate the resistance of Q. So I will change the value of P to 4 different values. Each case I will get a different balancing length L, and each case I will calculate the value of Q. Then I will take the average value of all those Qs. So 5 such readings I will take. The average of that will give me the average value of unknown resistance Q. Understood? So in the next video we will see how to measure the next video we will see how to use a potentiometer. Potentiometer is also very similar to this setup. Concept is very similar. Okay.